Good morning, everyone, or afternoon, depending on what class you're in. This is Mr. Johnson, and Miss Whaley and I decided that we're going to make a video so that you guys can still fill out your notes today while we're at our meetings. But we had to go a little old school for this, so we're going with the traditional paper and pen. A little easier than the parchment and feather quill that I had to use when I was in school, but we'll make do for today. So the notes that you should have should look something like this, without all the orange junk on here, because that's what I wrote for my notes. We're going to go through the first page, and then the next video is actually going to be the next page, which is out of order here. But if you want to follow along, we're going to fill in these different charts, and for these first two, we actually aren't going to do the bottom two rows here. So if you'd like to take a second and fill out this end behavior recap chart, you guys should have done this yesterday, and hopefully this won't be a problem for you guys. Okay, what I'm going to do is I'm just going to fill in the chart here, and we're going to see if you guys can make some of the connections between these different things and our polynomial and where these come from. So we have our parent function, we have our degree, our end behavior. The maximum number of turning points is the last thing that we're going to do. Okay, so real zeros and multiplicities we aren't going to be worried about here, and that is because we're adding here at the end. It doesn't work if we have just a number hooked on at the end. This is a party pooper. Question number 1, if we have y equals x minus 1 to the third power plus 8. Our parent function comes from just doing the math and expanding this thing out. So if we wanted to, we could take x minus 1, and we need to multiply that by x minus 1, and multiply that by x minus 1, because we have one of these, two of these, three of these. That makes x minus 1 cubed, and then at the end we're going to add 8. If we were to do all of that math, we're going to come out with something that is going to be an expanded form. So that would be y, and then we'd have like x times x times x would be our first thing, which is x cubed, and then we would have a bunch of other stuff and probably a constant at the end, and I believe our constant is 7. So all of this stuff in here I don't really want to do the math for, and I just want you to understand that we could expand this. Okay, right now it is in factored form. So when we expand it, the parent function is actually this first thing. So let me get my highlighter here. If we were looking for our parent function, we have to look at that first term, the term with the biggest exponent. So our parent function in this case is going to be y equals x to the third power. And that just means that our polynomial acts like our parent function and acts like that for the most part. Our degree goes along with that. Our degree is 3. Our end behavior is going to be down on the left and up on the right. The maximum number of turning points, which is probably something new to you guys, is going to be 2. And we'll see here if we can make a connection after doing the second problem. For number 2, if we have y equals negative and then x plus 2 in parentheses to the fourth power minus 3, if we were to expand that all out, our parent function will be y equals x to the fourth. Okay, so just doing the math and crunching numbers and figuring that out. Our degree is going to be 4. The maximum number of turning points, and sorry, in the notes these were switched around for the rest of them. Actually, the first one was switched around. But in the notes, we have maximum number of turning points is next. That is going to be 3. And then our end behavior depends on our degree, and it depends on our sign over here. So we know that we have an even degree and negative sign here, so we're going to be going down and down. Now, drawing connections between these two different examples and figuring out how do these things work is hopefully going to be something that you realize here. Our degree comes from our parent function, okay? So the degree and the parent function are closely related. We have 3 here, we have 3 here. We have 4 here, we have 4 here, okay? So those things are connected. Okay, so I'll draw a little connection arrow there. Our end behavior depends on the degree and the sign out in front. The degree and the sign out in front. And hopefully you should have learned that the last 2 days. The maximum number of turning points, though, okay, this number is just our degree minus 1. So we can get to the maximum number of turning points by taking our degree and subtracting 1. Okay, same thing down here. 4 minus 1 is 3. That is the maximum number of times that our graph is going to turn. And when I say turning point, what do I mean? Well, I mean that if we were to graph this, have an x and a y axis, we could turn 3 times. So our graph can go up, we can turn and go down, we could go turn and go up, and we could turn and go down again. So we have a turning point here, here, and here. And that is the most number of times that we can turn. Now we can turn less than that, because as we know, y equals x to the 4th looks something like this. And it just goes up and it goes down. Okay? And we only have 1 turning point here. So either of those could be possible graphs for our polynomial here. Teaching a graph is a little tricky for number 2, but for number 1 it's not so bad. We know that it looks generally like y equals x to the 3rd power. Okay? So for our graph, if we wanted to just make a sketch, all we'd have to do is say, hey, it looks somewhat like x to the 3rd power. So I'm going to dot x to the 3rd in here. Okay? Now we're going to take that and we're just going to move it around on our axis, either left or right or up and down. So this minus 1, as we kind of learned with polynomials, is going to actually move that whole thing to the right, 1 unit. So we're moving that to the right, and then this plus 8 moves that whole thing up. So we're going to move and maybe start here at 0, 0 is a nice spot. Move it 1 to the right for that, and then up 8. So we're going to be somewhere up there. And then we can draw kind of the same pattern. So we're going up, and then right here we are going down. And it should look something like that. Okay, so that's an easy way to sketch our polynomial. Now for number 2, we have these 2 different cases. So it's going to be a little tougher. And actually I had to check this on my calculator to see if we have 3 turning points or if we only have 1 turning point. Turns out we only have 1, so it's this bottom case. But we can kind of do the same reasoning as we just did above. Okay, so we have our x and our y. Now this negative, first off, means that we're opening down. Both of these cases open down. The plus 2 means we're moving it to the left 2 units, so over here. And then the minus 3 means we're moving it down. So right here is going to be where that point would be. And we can draw to the right and draw to the left because my end behavior here says that we're going down on both the left and the right. Okay? So all of these things should hopefully agree with our graph. For question number 3, we're going to go a little faster. And actually we can do the real zeros and multiplicities for this one because we aren't adding at the end. Okay? That was really the only thing that stopped us from doing it for 1 and 2. So our parent function, if we were to expand that whole thing out, is going to be y equals x to the 5th power. Because we have x times x times x times x times x. So x times itself 5 times is x to the 5th. Our degree then is going to be 5. Our maximum number of turning points is 1 less than that. So that is going to be 4. That means we can change directions 4 different times. Our end behavior, since we have an odd function, since our sign up here is positive, is going to be down on the left and up on the right. Okay? Our real zeros, this is new, comes from our factor up here. So our factor is this x plus 8, and what we have to do to get our real zeros is set that equal to 0. So we will have 0 equals x plus 8, so very similar to what we did with parabolas and quadratic functions. And we have to solve for x, so we're going to subtract 8, subtract 8. So negative 8 equals x, and that is a real zero for this polynomial. That means that is where we are either going to touch or cross our x-axis. So real zero is x equals negative 8. Now, multiplicity is just a fancy name. It's a fancy name for an exponent. Specifically, it is a fancy name for the exponent that goes with this factor or with this 0, okay? Because this 0 comes from that factor. So, what exponent is with that factor? Well, it's just going to be 5, okay? 5 is the exponent that goes with this factor, x plus 8. So, this real 0 will have a multiplicity of 5. So if we were to write that out, we could say negative 8 has a multiplicity of 5. Okay? So negative 8 has a multiplicity of 5. That's just saying this factor, x plus 8, has an exponent of 5. And there is an important trend that happens depending on whether our multiplicity is odd or even, okay? In this case, it is odd, so I'll write that in here just as a note. This is an odd number. So, if it is odd, our graph, let me see if I can fit it in here, or on my stand here, our graph will cross the x-axis. And that is because it is an odd multiplicity. If we have an even multiplicity, our graph is going to touch the x-axis. Okay? So there's a difference between if we have an odd exponent up here or an even exponent. This is kind of important. So for our graph, if we wanted to sketch it, okay, we know that our 0 is here at negative 8. So we can go over to negative 8, comma 0, and we know our graph has to go through that point. Now, on the left, we know we're going down, so to the left of that point, we have an arrow down, and to the right of that point, we know we are going up. So over here, we're going to be going up. Now, it looks generally like x to the 5th, okay? Now, we know that x to the 5th looks something like this, and we are crossing through that 0. Okay, so we go through that point, negative 8 comma 0, and we're going up and we're going down on the left. So an easy way to know that here at negative 8, we're going to be crossing the x-axis, and it looks generally like that, okay, because of our end behaviors. So an easy way to sketch that graph. And actually, when we get more complex polynomials, the factors help us out even more, the factors and the multiplicities. So, we're actually going to go to another video, and hopefully that will help you guys out with the next problems. So, thank you guys, and that's all I got.